Hey folks, I'm here to talk to you today about how you can send information between two microcontrollers across the internet, even if they aren't necessarily internet connected devices to begin with. Some microcontrollers have Wi-Fi modems or Bluetooth modems bolted onto them, and so you can use them to connect directly to the internet. They can act as web servers or clients. They can request information. They can receive information or serve it out to others. Um, but that's not always the case. The microcontrollers that you all have in class don't connect to the internet. They can speak serially to a computer, but that's kind of it. So I'm going to demonstrate to you a little bit of a hacky way of doing this. It might be interesting for you to think about how you can communicate with one another using, not necessarily having to go through Zoom or email or something like that, but you can set up some other kinds of physical devices for input and output through the internet. So to start out, I'm going to talk about this service by Adafruit called Adafruit.io. It's a sort of a data aggregation site where you can send data up to them and they will hold on to it and then they will spit it back out to you. It's relying on APIs, the thing that we talked about in the previous set of videos. So in this case, what I'm going to do is I'm going to show you how to send and receive data from an Adafruit feed and just using p5.js, and then I'll show you another example in the next set of videos for using this with two microcontrollers. And so while I'll just be doing this inside of my apartment, you could all have the opportunity of doing this, between one another, at a great distance. So this is the website here, Adafruit, uh, io.adafruit.com. You could just go to adafruit.io and we'll resolve to this too. Um, you can create a free account. It's a really painless thing. And when you do, you wind up getting presented with an interface like this. So they've got a free plan that allows you to update up to 30 times a minute with information. It'll store your data for up to 30 days. It's got a couple other sorts of things. You can have up to 10 unique feeds at any given point in time. So we're really just going to be using one of these things. I'm kind of maxing out the data limit, and it's working pretty well so far. So the way that they've got everything sort of built up around this is this idea of like feeds and dashboards. A dashboard is basically just a place where you can visualize your data online. We won't talk about that at all. We're really just going to focus on the feeds. And so inside of my feeds, you can see that I've got one right here called test data. I know it's very original, but it's what I came up with. And so here you can see a plot of data that I've been pushing out here over time. Started the other night, and then there was this lull before I got back to working on it. But here you can see I've been continuously updating information for a while now, sending stuff out roughly every 3 seconds from a processing sketch. So their API is nicely documented. They ask you to, in order to send information up to them, you need to create a group. So you would click on create a new group, and then you create a group. By default, you've got one called default. And then you need to create a feed inside of there. And a feed is really just an arbitrary place to stick information. So you can call your feed whatever you like, and you can send whatever you like to it. You just want to make sure, as in any sort of, you know, building any sort of protocol, you just want to be consistent in it. So here I've got one called test data, um, and I'll just show you what it's going on inside of here. So when you create a new feed, there's nothing in there by default, but since I've been populating this for a while now, there's all this information in here. So there's some information here about the feed info, right? So the name and the key. So the key is in the key value pair that we send up to Adafruit.io. This is how we identify that we're speaking to this particular feed. Um, you can see right here, this is how we connect to the API. They give it to you pretty straightforward right here. Um, and you have the option of making your feed public or private. I've made mine public, so anybody who wants to go and look at this data can. It's actually just noise that I'm generating right now, so it's not totally useful or helpful, but it's a good test case. Um, you can see you can also look at the history, which gives you this nice plot. You can turn that off and you can send more data if you do that. It'll send you notifications if your feed goes down. So if you've got a remote sensor somewhere and it goes offline, you'll get, you'll be pinged by it. Um, and in order to do anything with any of this, you need to have an API key. So this right here is my key information. All this is going to be blurred and or edited out because I don't want to, this is not something you should be sharing publicly. But it is, you do need this information, both your username and in particular the active key. And you need this in order to send data up to your feed. So I'll show you exactly how this works with p5.js. I've got two sketches here in the background, and that's what's updating this right here. The sketch on the left here is sending information to the feed, and the sketch on the right is downloading the information on the feed. So these are communicating through this remote server. And so I'll talk about what they're doing, what they're sending out and receiving as we go through. I'll talk about the sender first. So I've called it Adafruit post data. And here at the top, you can see I've got a variable called URL that has the route, the path to the data feed, right? And so this is pulled down from this feed info right here. So I took this API link right here, copied it, and just pasted it into this URL field right here, right? So you can see it's io.adafruit.com, API, v2, my username, feeds, test data, which is the name of my feed, and then data, just so it knows that this is, I'm posting stuff, right? And then I've got a couple of variables here. One is for determining where this circle gets drawn, and the other one is just a counter to keep track of things. I create my canvas. And what I'm doing here is I'm I'm using the noise function. So as opposed to random, which just is a random plot, the noise function creates a little bit more of a naturalistic motion. So it's a slightly more pleasant thing to look at. So I'm using the noise function to draw the location of the circle in my sketch as it moves back and forth in a pseudo-random fashion. And then once every 3 seconds or so, it draws a red dot and sends the location of that red dot up to my feed. So I'll walk you through this right now. Here I've got the draw function. I'm drawing a big semi-opaque rectangle across the canvas, which is how we're getting this kind of fading effect. And then I'm generating some noise right here. So this is just an input value that I'm incrementing a little bit each time I go through the draw loop. And then I'm calling the noise function right here, multiplying it by 255, and having that come out as my data, right? So that's actually getting published right here. You can see that get updated every couple of seconds there. So I'm using that as a way to draw the circle somewhere inside of the sketch. And then since I can only upload information 30 times a minute, I'm sort of rate limiting myself by using a counter that updates, and the sketch tries to draw something on screen every 60 times a second. So, if I did that every time through the draw loop, I'd run out of, it would basically rate limit me after half a minute. So, I'm sorry, after half a second. So, what I'm going to do instead is just say once every 3 seconds. So I've got this counter right here that's basically just counting up to 180, and I'm just using mod 180 to say whenever that equals 0, that's when we're going to send up the data to the server. And so here you can see I'm printing it out to the console. So this is the data, and then I'm drawing that red dot at the location. And then I've got this function right here that I've called send shit. So this is the shit that I'm sending up to the server. Uh, so I'm passing it the argument of data, right? And so data is the position of the circle on the x-axis. And inside of this function, you'll see this is, I'll walk you through this a little bit. This is the only part of this that's probably going to be super confusing for those of you that aren't familiar with network communication. I've got a, a, a variable here called post data, and this holds both the key value pair for the information that I want to send. So you can see right here, there's the value and there's the shit that I'm going to send that gets passed in when I call this function. And then I've got my Adafruitio key, which I've blanked out here, so I don't have to spend a lot of time editing this later on. But this key is something that you pull from the link up here in the Adafruitio key. And so these get sent, and we're making a post request to the server. Now, this is a kind of HTTP request that sends data somewhere. The related one is called get, and we'll use that in the other example. So here I say let post data equal, and then I've got uh, these two values, these two key value pairs, so value and then the number that I want to send, and then my key, which I need in order to access and post the data up there. And then here, down here, this is where we actually make the HTTP post. So I'm saying HTTP post, and then I pass it four arguments. The first one is the URL that I'm referring to, which I've defined back up here. This is my feed and the kind and what I'm posting to it. After that, I'm saying what kind of data I'm passing on. In this case, I'm passing JSON. So again, if you look at the post data, this is formatted as JSON. And then the next thing I pass is the actual information itself. So you can see here's the variable post data. It passes the key value pairs of both the data and my access key. And then the last thing that it wants is a callback function for when this is completed. So what happens is when we send this data up to the server responds with some information for us. And so I've got this anonymous function right here that takes the result and then just prints it out to the console. And so you can see here, down in the console, every 3 seconds or so, I get the value to send, right? And then afterwards, I'm getting this other thing that says object, and then it gives some information. So it gives the object ID, the value that's sent, and you can see that that matches up to the value that's printed out right here. The feed ID, this is an internal number for them. I could access my feed ID that way. The feed key is the test data, right? So this is something that we identified inside of our feed info. And then the date that it was created at. There's some additional information here, but it's just diagnostic information, right? There's nothing in there that we absolutely need at this point in time other than to know that we actually sent data at the right moment. It'll throw an error if you try to send too much information. It'll also throw an error if you formatted something poorly. So make sure and look at this. Keep this callback function in there just as a way to sort of debug things. But that's it. So we're randomly generating a position of the circle on screen. Every 3 seconds, we're saying, take that location, draw a red dot right here, and send it up to the server. So if we look at the server here, we can see these are the values here. So this is the most recent value, 97, 97. And you can see these update really quickly, right? So 108, 108. So that's really nice to see that it's actually going there. And it's all kind of like bunching up here, but you get the idea that this is where all the data is located, right? So on our receive side, what I'm doing is I'm taking the points in time where this red circle gets drawn once every 3 seconds, and I'm pulling the data down from Adafruit.io to this other sketch running in this other browser window, completely independent from this other one. And then it's every 3 seconds, it's polling and updating. It's a red circle in this sketch right here. So I've got the two working in sync with one another. Um, so here we can see I've got a URL to retrieve the data. It's slightly different than the post one. Here we don't actually say data, we just ask for the feed itself, right? And then inside of my draw function, I'm just saying every 3 seconds or so, call the get data function. So if we go back down to this get data right here, stop and restart this. We can see I've got, there we go. We can see that I've got you can see the dot appearing over here. And then inside of get data, I've got this local variable called data. And so this will hold the most recent value from the feed. And so HTTP GET makes a request from the server, and it has so when it requests a URL, that URL then gets returned to us, and this is basically the same sort of like the get JSON that we saw previously, right? So when I request this URL, you can see this is the feed that comes back, my username, owner ID number, the name of the feed. If I had a license on here, description, it would be up there. It's public. And then the thing that I'm interested in is this last value. So the last value in this is whatever was sent most recently to the server. So uh, inside of here, in the HTTP GET, we pass the URL. We say what kind of data is going to be coming back. It's JSON. And then we say, here's an anonymous function for dealing with the response. And so we pass the response. First, we just print it out down into our sketch to make sure we know that we're getting the right thing. And if we look, we can see all that information squares with what I saw when I just called it directly through the browser. And then here, response.lastValue. Last value is the most recent thing that was published to the server. So this is how we access this. If you remember from those previous videos on accessing APIs, this will basically pull out and retrieve that data. And here it stores it into this variable. And I just take this and I draw an ellipse on the screen at the appropriate position. And I print out the location of it. So here we can see if we hold these two up side by side, we can see there's like a delay. And that's because of just the timing at which I started, but we'll see a red dot appear here, and then a red dot appear there, here, here, here in the center, here in the center again. So you can see that these two are, it's a one-way communication, right? But we're able to share information from one sketch to another through the internet using these tools. It's not real time. There is a delay here, and that's because we don't want to overload the servers of the nice folks who are, providing the service to us. But it works, right? And we don't need to go super deep into WebSockets or any sort of technical sort of issues like that. We're leveraging some existing frameworks here and hopefully going to be doing something interesting with them. So this is the start of this. I totally encourage you to check out these sketches that I've made. Make your own feeds. You'd need to swap out these variables here, the URLs, your IO key, right? And then it would be also probably useful to generate some of your own data back and forth, right? So maybe you're clicking somewhere in here and you're sending that over this other sketch and drawing something there based on where you click in this. And then you could also try this with a partner. So two of you could collaborate and set this up where one person is drawing in a window and somebody else in another location is accessing it. all this is happening, looks like this is all happening locally on my machine, but I promise you, all of this is leaving here, going up to a server somewhere else, and then coming back down. So yeah, give it a whirl. And when you come back for the next video, we will set this up so we can send data from a microcontroller through these P5 sketches to Adafruitio and back down to another microcontroller.